Inside modern industrial machines, every movement must be measured with precision. This precision begins with a device called an ENCODER. An encoder is an electromechanical device that converts mechanical motion into electrical signals. These signals can be digital pulses or analog outputs, depending on the application. The control system uses these signals as feedback from the machine. This feedback allows the system to know the exact position of moving parts.
It also measures rotational speed in real time.
And it determines the direction of rotation instantly. Together, these values form the basis of closed-loop motion control. The most common type is the rotary encoder. Rotary encoders measure the angular movement of a motor shaft. Incremental encoders generate pulse signals as the shaft moves. Channel A produces the primary pulse signal.
Channel B is shifted in phase to identify rotation direction. Channel Z gives one reference pulse for each full revolution.
Because incremental encoders do not store position, the machine must perform homing after power loss. Absolute encoders keep position information even after power interruption. Parallel absolute encoders transmit position using multiple output lines. Multi-turn encoders can track several revolutions without losing position. Linear encoders measure motion directly along a straight path.
Optical encoders use light passing through a coated disc for very high resolution.
Magnetic encoders detect magnetic field changes and resist dust, humidity, and vibration. Mechanical encoders use physical contacts but have lower precision and shorter life. Resistive encoders convert resistance changes into electrical feedback signals. Encoders are used in CNC machines, packaging systems, textile machines, presses, and door control systems. They integrate with PLCs and servo drives to improve precision and synchronization.
By improving accuracy, repeatability, and efficiency, encoders have become essential in industrial automation.